Well, we're sitting here with Joakim Juhl, if I pronounce it correctly.
It's good enough.
Uh, Good enough, yeah.
Yeah.
Sorry. You can say it probably 10 times better. From OePhi Cables, at least that's how I would pronounce it in Dutch. But how do you pronounce your brand?
Well, it's actually interesting because every country has each its pronunciation. So maybe we're just a multifaceted brand in that sense.
Yeah,
So I say OePhi,
OePhi.
and
Okay.
I'm not sure that is the right way. I think it's however it works for you. The
Mm-hmm.
idea behind the name is that the OE is a more international version of the Danish letter Ø, which is like an O with a cross. Uh,
Yeah.
and that letter also has a mathematical meaning, which is zero
Yes.
sum. And then the
Yes.
phi refers to phase deviation.
Yeah.
So that's
Phi.
kind of
Yeah.
picked up from Greek letters and that specific understanding in physics. So that's basically what the brand is about. That's the philosophy behind what we're trying to achieve.
Yeah.
It can never happen like perfectly, but
Nope.
we try to kind of understand the problems behind it and deal with them. Yeah.
Well, we tested some cables of you, and well, it was more like a follow up on our large investigation of 32 speaker cables and 32 interlinks, which you read. Thank you for that. And of course, you read your own review of the OePhi, OePhi,
OePhi.
OePhi, OePhi
Yeah.
speaker cable. We did a couple of months back, I think,
Yeah,
October or
sometime
something.
last year. I'm not sure about the
Yeah,
timing.
sometime. No, me neither. I think it was October last year. Um, it took a lot of time before we could sit down and have a talk about it, but it was mostly due to me that had a kind of a large extended holiday that I really needed. And yeah, well, the start of the year was quite chaotic and quite busy, at least for us. But here we are. Thank you for your time and your persistence in having this talk about cables, because that's actually what we're going to do. We're just going to talk about what makes a cable a good cable and what do you think is necessary for creating a good cable. And maybe we can share some knowledge about that. Um, First, what is your vision on a good cable? I'm really interested.
Yeah, so I think the basic concept is to have a cable that has the least impact, audible impact on the signal.
Yeah.
So the less the cable affects, the less damage it can do. So I'm not in the belief that cables in general can do anything good. So it's about
Mm-hmm.
understanding what they do that has the major effects on audibility and then trying to figure out how to minimize those effects. And the reason why I say audibility is because that is also where I think a lot of the epistemic challenges lie, because we may hear cables, but then exactly what is it that we hear that is kind of what is the physical meaning of that? Is that
Mm-hmm.
as I claim the time domain, or is it something else? And it's not something I think we can easily just say now we just sorted that. It's just done and over, and then
We
that's it.
figured it all
Uh,
out.
so I think it's more it's more about trying out these things and then see what works for each of us, because
Yeah.
I do think that it's great that cables are not the same. I think that consumers should have options to choose from, but
Mm-hmm.
I also do think that cables do have in many cases a lot of very harmful effects on the signal. And sometimes it's deliberate, because manufacturers wants a particular effect in the sound, because that's in a commercial sense sometimes easier for consumers. Like if you take this cable, it
Yeah.
will always have this effect, and then
Yeah, it's different, so it's better.
yeah.
That's a
so
lot
so
of.
so I think
Yeah.
in my opinion that's not a good cable. I'm not saying it could not be the right cable for somebody else, but that is in my opinion not what I think a cable should do, because um, a cable may have a pleasing effect now and in one particular kind of system, but that is only if it hides something else that is actually a problem that you should solve. So I think a good cable would have minimal effect and would then also be more revealing of other tendencies in the system. And this is also, I think, one of the big challenges as a cable manufacturer, actually trying to go much further in that direction that I think most commercial brands actually try to, is that we believe that there is a more, I think, a better way of doing it where we have less audible effects. However, when we then also achieve this, then if you put in our cable into your system, it will probably not have the same effect as it would in another system or for another customer, basically because you're not adding an effect, you're actually just removing other effects, whatever they are and whatever that reveal. So sometimes it can be a little bit of a challenge because, well, how do you hear something that has less sound? Which of course is my claim, but it's actually it makes it less easy commercially because we're not adding a color. At least we're not trying to.
No. Well, one thing that struck me was the extremely low capacitance, and that's due to the geometry of your speaker cable, which is two, pairs. One pair, but you had a spacer in between, so there's very little capacitance in the speaker cable, and I think that's a good thing because it improves speed, which is what I noticed during the big investigation we did. Low capacitance, higher speed, and less variance in delay, so the timing is more accurate. I think it also has an impact on coloration, and one of the things that struck me is that if you compare a lot of cables, then you actually start to notice the differences. You need to hear a lot of different cables before you notice that they all do something. There is no perfect cable out there, but there are cables that have less impact on the system coloration and others have a lot of impact on the system coloration. And the funny thing is they all claim the same. We want to have as less coloration as possible, but there are very few that actually do that. But how did you come to your philosophy and your way of working? I mean, there is a clear strategy in all your cables.
Yeah.
So how did you figure it out, how to make that kind of cable?
Well, I think it comes down to my design approach. So my background is I have a bachelor's and master's degree in engineering design as well. And then I have been working as a scientist for quite a few years. And I think my approach to audio has never been about making one product, voicing that so it's nice. It has always been about, for every product I make, whether that is a speaker, a cable, or something else, it is to try to understand some systemic tendencies or mechanisms that govern these outcomes. So I think my approach to cable making, because I started experimenting with cables back in, I think, 2007, something like that.
What triggered that? I mean, a lot of scientists say, whatever, it's a piece of copper and they all do the same, so who cares?
Well, I'm curious. I'm really curious. And also I think even though I'm a scientist, I think I was struck by audio before I went to engineering college. And I think my basic outlook has always been that it's about what matters, like for the perception of audio, like how you perceive music and sound. And then we can use different technical ways of making sense of the world and what we think is going on. But these are not going to determine the outcome of the perception. These are more suggestions about what might be at play. And then we have to be extremely careful about how we try to correlate these things, and especially claiming causality. That's when you have to run out the door. You have to just leave. If somebody says it cannot be because blah, 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 and then, okay, thank you for coffee.
Yeah, yeah,
Let's
yeah.
talk about something else. No, it's just because then you don't understand the system. And this is if you actually work with science, you're usually actually you have to be extremely humble about that the system you're talking about is immensely more complex than what you can actually fathom, measure, theorize, etc. So
Yeah.
so we don't know how photosynthesis works. We know about photo that it happens right out there, but we
Yeah.
actually don't know how it works. It's just too complex. And it's not that we
Yeah.
haven't had chemists, like the best chemists in the world, to look at this for 70 years and more, but they still haven't figured out. So when we have then
Mm.
have audio, which is such a small domain in terms of what science and engineering is
Yeah.
actually interested in,
Yeah.
and then assuming that we know what we need to know, then we are pretty far out, actually. So I think we have to go another way and say we have to accept immense humility, and then say, well, we are hearing stuff, that's for sure, we can hear it.
Yeah.
Trained
Yeah.
ears are usually very much aligned about what they're hearing. They may have different, not perceptions, but rather more different tastes, which is fine.
Opinions. Yeah.
Opinions, that's fine.
Yeah.
But I think most trained ears actually do have a um, quite good correlation between how they characterize sound of
Yeah.
these things. Um, but that is something we just have to say it's not just subjective, it's intersubjective in the sense that many people perceive the same things in ways that are actually kind of it's interesting that we are that perceptive. And then on the other hand, we have different scientific explanations, but we then have to be super careful about when we think an explanation is actually helping us and when it's just coming up with some guess. And maybe
Mm.
what it's guessing is potentially true, but is so marginal in comparison to the wider picture of all the complexity going on. So it may actually
Yeah.
not be that relevant. And this is one of the things where my approach has been first, I started actually developing loudspeakers since I was 15.
Oh
So
yeah. Okay.
I didn't have any measurement equipment. I only had like an old NAD receiver. I didn't have a lot of means, but I found out that tweaking the crossover like that made all the difference.
Yeah. Yeah.
And
Yeah.
we're
Yeah.
talking about like minuscule differences. Like let's say you have a third order crossover, like a slope, and then just
Yeah.
tweaking that one coil that shunts the signal just a few percents, that made like
Yeah.
that was make it or break it. So in my understanding, these small subtle differences has always been paramount to the difference between something that is kind of okay and something that is actually
It's
as it
great.
should be.
Yeah.
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 And
True.
that I think I brought to cable, like the way that I design cables, because understanding like, well, now I didn't figure out how to do speakers the way I do now, but I did
Mm-hmm.
come quite far even at a young age back then. But then I understood, okay, if I have a better source, if I have a better amplification, if I have better cables,
Yeah.
that's going to matter as much, even more than this last fine tuning of a loudspeaker. So it was the necessity to improve my abilities to hear what was going on in the system that ultimately also led me to look at cables. So I had
Yeah.
a couple of different cables. I had Nordust, I had a Chord, a name cable, musical
Okay.
fidelity,
Yeah.
MIT. I had lots of different interconnects, and they all sounded very different. Um,
Very different. Yeah.
and some of
Yeah.
them were kind of good in some ways, and then terrible in some other ways. And then, you know, so it kind of
It's
like,
also the matching because I remember very vividly that I had a pair of Magnapan loudspeakers,
yeah,
old ones, and they absolutely sounded horrible with MIT cables. I
yeah,
don't know why, but it didn't work at all.
yeah,
But they work perfectly fine with Avalon because they're designed with Avalon and Spectral.
yeah,
And that is like the magic combination. And I thought, wow, I want these cables. And I tried them at home because I was working in a store back then. And it was horrible. It was very in your face and completely out of balance. So Yeah, you have to try a lot of combinations as well, and some work fine with one pair of loudspeakers, but they work horrible with another pair of loudspeakers. And
Exactly. So what I did
yeah,
was just I did some basic experiments. I just
yeah,
got some
good.
really cheap connectors. I bought some copper wire in a like a store like that had some electronic stuff.
Hmm.
I bought some what's it called, like the cotton you use for shoelaces, like really basic stuff. And then I
Yeah,
just did a lot of experiments. And I think for
yeah,
me, this is where I think, all development, like all serious development, has to come from. Not buying some
yeah.
solution off the shelf, but actually trying to, in as far as possible, to go and do your own experiments on the fundamentals. So what I could do from the get-go
Yes.
was to experiment with different sizes of the copper, using pure silver, using different
Like
dielectrics.
diameter of copper.
Yeah,
You varied it. Yeah, it
yeah,
makes a huge impact.
it does. And then if
Yeah,
you calculate the effect on self-inductance, usually people
yeah,
say if you make it thinner, you will have less self-inductance. Actually, the opposite. However, the difference is relatively small. So something
yeah.
else is
It
going
is.
on, and this is
Yeah,
kind of my approach to this is never to say the model claims this and that, so it has to be that way. It's rather to say these are the differences that make sense when I do the experiments, like the concrete, like let's build it, listen, and then change only one thing at a time. And then we can
yeah.
look at what are the models prescribing and then say, okay, so if the model can only describe a very, very small difference and the audible difference is very large, something
Then there
else is
has to be
probably going
something
on.
else.
Yeah.
Yeah, exactly. Because I changed the material of the grounding wire in a single-ended interlink, and it shouldn't have a huge impact, but it does.
And you know why? It's because in many cases, when you think of the signal, you have to really be careful about the mental model that you apply. So in many cases, I think even very knowledgeable engineers, they say, okay, so you have the signal going out and then you have the signal going back. No, 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 because that's if you have
No.
DC. If you have DC,
Y-
that's correct. You kind of have
Yeah,
each electron has to push the other one.
yeah, yeah,
But
yeah,
that's
yeah.
not really how audio signals
AC
travel.
works.
It's more like
Yeah,
you have like a signal and a return. You need at least
yeah,
something like that. And
yeah.
if you don't have a specified return, it will find some return path. It's just not something you designed. So ground planes
It
and
will
stuff like
find
that,
a way back.
yeah, yeah, it will find some way. The question is whether you decided it or whether it just
Yeah,
decided it
it just
whatever it
happens.
it,
Yeah,
it liked that on that day. So the trick is that you have a voltage potential that you apply at one end, like like really like a shock, and that
yeah,
voltage
yeah, yeah,
potential then like a wave travels down through the cable.
yeah.
So that's also why, like, if you orient the copper, it will
Mm-hmm.
sound different depending on whether you
Yeah.
orient it this way or the other way.
Yes.
So even though
Oh,
the current should go both ways in an AC signal, but the
yeah.
direction of the signal travels more like a wave of the potential, which goes partly, the current part is in the conductors, but then you have all the electromagnetic forces around the conductors, which
Yeah,
then are
yeah.
just to some extent confined by the conductors and all things around them. So in some ways, we have to think of a potential traveling from one destination, from one place to another, and
Mm-hmm.
and that is a different mental model, which is also
Yeah,
to say that any signal that we can perceive is usually above DC. It kind of has to, and then
mm-hmm.
we are actually talking about a potential difference that has to move, and that is a different way thinking of, like, you have if you take like a long lead of something and you twist it like this and you see the wave going down, or
Yeah, yeah.
you
Oh,
drop a
there's one thing I have to mention to my viewers.
yeah
I'll link a video to Black Phoenix or Alpha Phoenix, I think it's called. It's a channel where the guy, he's extremely smart. He actually visualized that wave.
yeah
So he had a battery. I don't know if you know the video, but it was absolutely fascinating. And he showed literally a video of current going through wires, and even wires that are not connected, like there's a circle
Mm.
in the current, even then it just bumps into a wall and slashes back.
Yeah.
And that was interesting because you can't actually measure current going, but still it's trying to find a way, like you mentioned before. Like if there's no return, it will go somewhere.
Yeah, because it's
It's
an
just not
energy.
how you designed it. Yeah,
Yeah.
it's energy. It has to go somewhere.
And
And
then you can kind of play
I'll link that
around with,
video.
and the composition of that energy can also change. So that's also why I think the parameters of the cable do have a large
Yeah.
effect, but maybe not
Yes, they do.
necessarily just because of frequency effects and so on, but because a
No.
lot of other things that we only know some of, but not all of. But we have
No.
both found that low capacitance, insofar that we can make a
Works.
balanced cable, like a cable that sounds
Yeah.
balanced, like frequency wise, like balance wise. Insofar we can
Yeah.
do that, then the lower capacitance almost always will have advantages. That's at least our
Yes.
finding. And
True.
it
Mine as
comes
well.
from it comes from just experimenting, because when you build your conductors and wires, we could just
Hmm.
place them close to each other. We can space them apart. We could
Yeah.
twist them. We
Yeah.
could
Yeah.
do all sorts of things. And what I found very quickly was twisting anything, that's just going to have an immense increase of the cable's own sound. So my
Yeah.
understanding of that twist is that, of course, you can do it as a balancing act. However, what you're really doing is that you're emphasizing articulation points, usually in the upper midband. So when you hear a cable that has this expansive top end, is that really more signal coming through? Or is it something in the time domain because of some form of resonance or energy storage? And
Mm.
when you have that, and you
Hmm.
also have pinpoint accuracy between, let's
Hmm.
say, the attack and the decay, then I trust that, okay, it's actually proper, it's proper headroom in terms of,
Extension of the frequency
extension and
band.
so on.
Yeah.
However,
Yeah.
in
Yeah.
most
Yeah. Yeah.
cases, it's not. And it's basically
Mm.
just because they have chosen to have, let's say, more capacitance that on paper seems to take down self-inductance, but then you also get these effects of a relatively uncontrolled, can see the way that that energy is traveling through the cable, that time domain seems to smear the
Yeah.
leading edge from the decay structures and all of that. So basically, what I found very early on was like the more spacing I can get away with, the better for controlling the signal, the better for both low end extension, but also for very fine texture in the sound. So like microdynamics also was equally
Yeah.
beneficial to this. However, spacing too far apart, and then you start to sense kind of a roll off. You start to feel like that everything sounds a bit the same, in the sense that it's kind of a bit laid back, and it lacks some kind of speed and articulation in the sound. So the presence
Yes.
is gone. So I kind of
Yes.
knew, well, if I could somehow keep
Hmm.
all the benefits of this wide spacing, but find some clever ways to then avoid the other things,
Hmm.
that could be very interesting. So I did a lot of experiments to try to figure out how to do that. It ended up with a very particular cable geometry, which,
Yeah.
in
It
my
is.
opinion, is controlling these things. So the audible effect is a very linear cable, but then we get the benefits of the extremely low capacitance and the conductor spacing.
But how do you do that with interlinks? Because I get it with speaker cable, and I can follow your theory because what I noticed when I was looking for other tests into cabling, there is nothing, absolutely nothing.
Yeah,
There's of course this big platform that we all know about measuring stuff, but they don't, in my opinion, they don't measure cables as you should. I talked to two friends of mine, and the whole thing about measuring cables is using the right impedances. Otherwise, you're measuring nothing because a speaker cable has you need to use 4 or 8 ohms as an impedance load, and with interlinks you need to use like 10 kilo ohms or something
yeah,
like that.
yeah,
Otherwise, you get totally different results.
yeah,
So we did, but we all know that frequency response will be flat anyhow with all
Yeah, more or
cables,
less. Yeah.
more or less. But it's funny that you mentioned timing, because there is a huge difference in stability of timing, actually. One cable is very flat, like your loudspeaker cable. If I vary the voltages, the timing differences are practically all the same.
Yeah.
So it's very stable in terms of timing and accuracy. And I noticed that my ears, at least my ears, but I know Martijn's ears as well, are very sensitive to stable timing. It gives you this calmness, and you hear it like it's supposed to be. Every song is very rhythmic and engaging. And if a cable is very unstable in terms of timing, and we measured stock interlinks like the red and white plugs,
Mm.
you know them, and speaker cables as well from the do-it-yourself shop. Some things are okay, but they all flaw in terms of timing.
Yeah.
It's very inaccurate. Like with small voltages, the timing difference can be huge, and with high voltages, they can be very small. So there's this instability in presenting the music. It's
Mm.
all over the place. And but I get it when you say low capacitance, because that has a huge impact on timing accuracy. Um, how do you do it with interlinks? Because you can't space the conductors like you did with the speaker cable.
Yeah, it's kind of interesting because you would assume that if you have to do a trade-off between inductance, self-inductance, and capacitance,
Yeah.
then the speaker cable, being the lower impedance, should have, like, it could better cope with capacitance, and then it would cope not as well with higher inductance, right?
No.
So in principle, you would assume that you would actually have, let's say, less conductor spacing with the speaker cable, and then
Yeah.
you could kind of get away with more conductor spacing with the interconnect due to the kind of the load impedance being so much
Yeah.
higher. It just isn't how our experiments turned out. So there is something else going on here. So with interconnects, what we're doing is that we do have, for that particular type of cable, we do have quite a lot of conductor spacing, but we also have kind of it's not just the spacing; it's also how we make the conductors themselves. Because at the end of the
Mm-hmm.
day, the capacitance doesn't come from the space alone; it also comes from other variables in terms of how
Yeah,
the conductors are
dielectrons
shaped
and stuff
and
like that. Yeah.
arranged and
Yeah.
so on. So it's not only
Yeah.
the distance. However, the distance is very easy to see. So oftentimes we point to that just to illustrate that this is substantially different from anything else. But with our interconnects, we also go for very low capacitance. But
Mm-hmm.
we found that we kind of get away with less spacing, but then it's also like we're using very similar techniques. It's the same cable model, but we kind of converted that to that application where we don't need as much current to be transferred as fast. So I tend to say that in some ways the speaker cable is the ultimate difficulty, because you need
Yeah.
both the speed and the timing, but you also
Yeah.
need to transfer current, because a speaker load does require current, and not only current from source to the voice coilless driver, but you also have the back EMF of the speaker. So you have an
Yeah.
immensely
It
complex
pushes
system.
back. Yeah.
Yes, a lot of
Yeah.
people forget that the damping of a speaker or system is probably equally as important, if not more important, than the drive.
Yes.
So
Yes.
if you kind of think of the speaker as not just something that acts as the amplifier tilted, but it acts as the amplifier tilted with some delay, a delay that is different for different, you can say, voltage drives, also for different frequencies. So therefore, you can see
Mm-hmm.
like you have some smearing going on already there, and then also
Mm-hmm.
that the speaker will kind of continue to make sound after the signal stops. And then it's about
Mm-hmm.
how the amplifier, through the cabling, through the crossover, etc., can actually then manage that kind of decay structure of the entire speaker. Um, so it starts to become something where we actually have very limited models to explain these things. So we can kind of measure what comes out of the speaker, but it's far more difficult to then say how should a proper waterfall look from the speaker, or these kind of
Yeah.
things where we are talking about, because that's also time. It's also time delay.
Yes.
However,
Definitely.
my understanding from doing a lot of experiments is because no matter whether I do speakers, electronics, or cables, it always comes down to understanding the timing properties. But the tricky part is that with the cables, the timing discrepancies are best understood at a very, very small scale, so small that we don't have active electronics that can actually compensate. So any DSP, any time reconstruction that is going on artificially is just not fast enough to do this at the correct scale that it matters for the human hearing. So what I found when I looked into the literature is that down to maybe 1 millionth of a second timing deviation is actually is something that we can perceive. And that
Yeah.
tells us that we may only hear 20 kilohertz or something, but it's probably not a dB or two at 20 kilohertz that are making a lot of difference. It's probably timing variations going all the way down into the mid range and further down. So this is what I'm usually designing for, to kind of understand these timing variations. When the crossover, it's about integrating the drivers. In the cables and everything like that, it's about managing, I would say, how the energy storage is managed. So when you have capacitance, it is also a way to store energy. So it means that any impulse
Yes.
will be stored in the cable and then released.
Yeah.
And that
True.
release is not good. It also
No.
means that
Absolutely
the
agree.
speaker's back EMF will not go directly to the amp. It will go into the reservoir of the cable's, you can say,
Yeah.
energy storage. So in some ways, the amp might want to do all sorts of things, but if you have a huge capacitor, basically the cable in between the amplifier and the speaker, that will actually prevent that amplifier to effectively control the speaker motion. So that's why I would say in many cables, they have a lot of copper, a lot of cross-section area. But if they then also have a lot of capacitance, it's not really going to do much. So what we do is that we
No.
optimize actually the cable parameters first and foremost, and then we try to, when we go to higher ranges, we then also have more copper or silver. However, we don't want to sacrifice the cable parameters, because we still find those are more important than just having a huge cross-section area, which is kind of like, if you buy something, then people are so what's the gauge of this cable? Like you shouldn't care about that, because there will be 10 other parameters far more important, and you won't understand it. So
Well, with interconnects, I totally agree. Doesn't matter. Conductance is not that important with interconnects, because we're talking about very small voltages and high impedances and stuff like that. So who cares? With loudspeaker cables, I actually did find a link between very low impedance and better sound.
but you say impedance, and impedance and DCR is not exactly the same.
No. I
the,
agree.
my position is that yes, it matters. However, when you just increase conductor size, or you just add more conductors, you usually change a lot of other things when you do that. So if you are to build a cable that is as precise, let's say, as a small gauge cable, but just scaled up, then you have to be very clever about how you organize that. And I think this is the tricky part. So having more cross-section area can be a very good thing. However, if you're not extremely careful about how you design it, that extra gauge can actually cause so much more harm than what it solves, especially if it adds to capacitance, because then I would say, from the amplifier is supposed to control the speaker point of view, that capacitance is going to limit that, even though you have lower DCR. So I think it's always a matter of, obviously, if you have a speaker cable having half a square millimeter of copper, it's probably going to be on the low side. Well, I'm not going to question that. But whether you need 3 square millimeters or 10 square millimeters, I would argue then you enter into where other things are starting to have more influence.
Yeah, like yeah, they interact with each other due to
Because
the
also
geometry,
if you
maybe.
and if you just do the basic calculation, say what are the power losses in the cable, they're
Yeah.
minuscule, really
Yeah.
minuscule. So that's not like, it's not the attenuation, and it's also not the conventional form of damping factor, because when you look at the output impedance on most amplifiers, even though some of them are very cleverly designed with feedback and all of that, but if you look at the actual raw power, like if you kind of say, okay, let's say the feedback is good when it applies, but it is always after the fact. But let's say if you have this immediate kind of, the amplifier needs to deliver current, you could just kind of say, okay, what's the output impedance of the capacitors? What's the output impedance of all the cables and the circuit boards and the output devices, and then the dumping resistor, blah, 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 so on. And then you end up also having in the loudspeaker, usually an inductor going to the coil, in most cases for passive. And,
Yeah.
very few manufacturers actually care enough to put something in there with very low TCR. So in many
Yes.
cases, we're talking about half an ohm or something, and that's not even a
Yeah,
bad
yeah,
case.
yeah.
So what is the difference between 0.01 and 0.005 going to do in the cable? I'm not saying you cannot hear difference, but I just don't accept that is the reason, because from that calculation, it doesn't seem to be the case. But something else
No,
is
no,
going
no,
on.
no.
So
Yeah.
what I found was that the reason why thicker conductors sound different, they sound more powerful than thin
Yeah.
conductors, is
Yes.
a combination of, I would say, two effects. Damping. So if you think of the signal and the current to some extent going through a very, very tiny tube, it's a little bit like a fluid. You will have a
Yep.
lot of friction against the sides. So
Yep.
you actually can produce very laminar flow, but you will also have turbulence effects and problems like that are more like they're kind of controlled, but you have a lot of damping. Then if you have a
Yes.
very wide tube, you can just push through a lot, but you have immense turbulence. So
Yeah.
from a signal point of view, it's a bit like yelling through a long corridor, and then you have a lot
Yeah.
of echoes, and you have a lot of, so it's going to sound louder, it's going to have more of that, but it's not really the signal, it's more additional artifacts added on due to, in my opinion, um, a compromised conductor and cable design. So you have to balance out that if you make them too small, they're going to overdamp anything. So this fundamental energy that you need to get to the speaker
Yeah,
seems
we'll
to
get
be
lost.
compromised. So
Yeah.
these hyperlitz constructions always have this tendency to sound restrained dynamically, even though they have a lot of cross-section area. But it's just like the strands are just so small, so it's a bit like trying to force a shockwave through a lot of microscopic channels, and that's going to kind of slow it down or prevent that immense energy. Um, on the other hand, if it was just one big giant tube,
It's
you kind of
yeah.
get this uncontrolled shockwave that just bounces off the walls and so on. So I think we have these effects. The question is
I really
just,
see a kind of a big tunnel in front of me now.
and then you
But
just
what
yell.
what yeah, you just yell and like, wow, that sounds
Yeah,
powerful. But what I noticed is with most hyperlitz cables, it sounds very bright
yeah.
and a tiny bit sharp, actually. That's what I noticed in the test we did. All the stranded cables had sort of a bright and
So
sharpness.
stranded and hyperlids, there's a main difference. So with a stranded
Yeah,
cable, it's just a lot of thin strands that are
yeah,
tied
wires,
together.
wires.
And with
Yeah.
those, you have actually a very complex system going on, because you have a lot of solid cores, but then those solid cores also send, like, they kind of have some resistance to the next one, and there might even be a bit of air, there might be a lot of things. So you also have small capacitive effects. So what they
Yeah,
all do
definitely. Yeah,
is that they can add some idea of more high-end resolution.
yeah.
However, that's noise. I would say that's actually
Hmm.
signal-induced noise due to all these capacitive effects of like a that is just added to everything.
Yeah, that's what I
So
think
that's
as well.
right. And then if you silver plate them, you can make it even worse. So that's great.
Oh yeah, yeah,
But
definitely.
what I'm trying to say with the hyperliths is like you have this where you kind of insulate all of them just by a very thin layer of
Oh yeah.
yeah. So that's a way of avoiding that strand interaction distortion or whatever. I think it was AudioQuest to use that expression. I think it's basically a contact resistance capacitant effect just all along the conductor. But anyway, if you then insulate all of those, then you don't
Mm.
have that. However, you then have these immensely constrained dynamical effects. So you actually need a huge amount of square combined square surface
Yeah,
area to
yeah.
overcome that to some extent. But like for me, it's just a limitation in the design in the first place. So for me, has been like trying to understand these various parts. Like you have capacitance, you have self inductance, you have you have this effect of what is the size and shape of the conductors. And also, I think what is usually not talked about is that the size and shape of the conductors is one thing. However, you're placing them into a cable geometry, so they're going
Yeah.
to affect each other. So it does matter how you actually orient them. That's not actually a given. So if it's round, it matters less probably. But then if you do other shapes and sizes, then you actually have to be very careful about how these things then actually interact. Because what happens if you have a signal that travels through, let's say, some very thick uh, copper inductors?
Hmm.
That is that capacitively the signal will try to go closer. So we know
Hmm.
that from piezoelectric drivers, right? So we can actually, or
Yeah.
electrostatic speakers. So we know that effect that we can actually use the voltage difference and the current drive and all of that to actually create physical motion. So what we have to understand is that while we can see the conductors moving, we also have to accept that it's very, very likely, I would say almost unlikely, that the current path inside the
Yeah.
inductors are not moving. They have to be moving in order for the rest to be moving. So that's the actual
Yes.
force. So having
Yeah.
a thick conductor means that you have more ability to move the signal sideways when you then apply a current. So when you apply a current
Yes.
and you change, let's say, the voltage and then the current, then that's
Hmm.
going to impact the cable parameters and the
Yeah.
timing and so on.
Yeah.
Um,
Exactly.
so it's about understanding all of these things and then saying, okay, how can we then apply that knowledge to then control this and then also go for the objective, which is the cable of no sound, which obviously doesn't exist, but we
Nope.
try in each our way to kind of limit some of these effects that we understand. So in our approach, it was about trying to build all of this together, and we haven't even talked about one of the most important parts, which is the insulating material,
Yeah. Oh.
because that is
I,
going
I
to store the energy.
I know that, but I'm gonna be very honest here. Uh, I'm not a physicist. I just am very interested in hi-fi, and I want to know why I hear stuff in our listening room, like change the cable. I hear things. I have some very clever people that help me out, and I use those a lot during my investigations. But even with months of work measuring more than 60 cables, I think I have discovered this of this whole story. Maybe even this. And you mentioned insulation. Um, I even didn't. I didn't even go there because it's so freaking complex to figure out what material does what. I did one attempt on hearing and measuring insulation because aerogel, the stuff.
Yeah, they use that in Audax drivers. It's like a very, very light, but relatively rigid material.
Very,
Yeah,
very light, very rigid, but they use it as an insulator.
yeah,
It's mostly air,
yeah,
and it insulates heat, and it's non-conductive. For me, it seemed like the perfect material for insulation. But you also have this form of tape, so I bought it and I used it. It sounded horrible,
yeah,
absolutely horrible. So I thought, okay, well, it doesn't work. But it triggered me in a way that I know that insulation has a huge impact on sound because it was the same cable as I listened before. It was I didn't use any shielding or insulation at all. I just built it and thought for the amount of twists, I wanted to know what was the ideal amount of twists in an interlink. And yeah, I figured that out a little bit. But there are so many variables and so much stuff that we can hear but not measure. It's
yeah.
really fascinating.
And
And
I think at the end of the day, it's also that while all of these things relate, so if you
yeah,
change the conductor
one
size,
thing.
you will probably end
Yeah.
up with a different amount of twists. Or if you change the plating material on the connectors, again, that might have influenced that. But I think it's
Yeah.
for me the real distinction between what I consider really good audio designers and those who are just
Yeah. Doing
making
stuff.
products,
Yeah.
but and they
Yeah.
might sell for various reasons, but I don't feel
Yeah.
that's where I would draw any inspiration to be honest. I think that difference is that you need to have a very consistent idea of what you're trying to achieve, and that
Yeah.
idea may not be what everybody wants, but it's just something where you really believe that this is the objective. And for me, I think when you listen to my products, I think people kind of get what that is because it's very consistent
Yeah.
throughout any product that released, not just the cables, but also the speakers and so on. And I think it's partly about being consistent in our approach, but it's also being consistent in not trying to make products to suit other discrepancies in the world, but rather to do something that is really honest and very kind of direct towards those objectives. And for me, lowering capacitance, getting the absolute highest signal transmission speeds, trying to figure out all
Yeah.
these
It's kind of the same as Nordost. They also believe in very low capacitance and high speed.
Yes, but then when you measure them, and you can see that in your own data, they're actually not very fast.
Well, no. That's not true. The interlinks were actually very
Okay, the
fast.
interlinks, for interlinks, they're kind of. I just looked at the speaker cables, but it's just to say that there's no intention for me to. I actually drew inspiration from Nordos way back when I started designing because
Yeah.
I actually think that
I get that.
they did have a very clear message about what they
Philosophy.
were trying
Yeah.
to achieve, and then for me it was about what can I learn from that, what can I learn from others, and then how can I kind of make my own knowledge base upon which I then
Yeah.
make my decisions in terms of how to design things. And I think the idea is that if you have these extreme transmission speeds and you have consistent, like not necessarily the lowest, but a very consistent
That's the most important thing. It needs to be
timing and
consistent.
impedance and so on.
Yeah.
And then
Yeah.
also I think for me it's about the pauses in the music. So
Yeah.
and I think this is why the capacitive part is so important at every
Yeah,
spec
because it releases energy
yes.
afterwards.
So even though it
Yes.
may look like you get lower impedance higher up with more capacitance, it's actually an energy storage effect that then compensates for the self-inductance, and then you have that energy being released, but uncontrolled.
Released afterwards.
Yes. And the telltale is if you hear, like if you have a 3D sound image, something that actually works, then if you can pinpoint discrete things in 3 dimensions, and the 4th dimension is then the time, being like you can hear the attack and you can hear the decay structure, also how that reverts.
Yes.
if you get that, you kind of know, okay, this tracks, it works. However they did it,
Yeah.
it works. And
Yeah.
for me, I just haven't come across other ways of doing it where I feel that this actually works to this degree. And
Mm-hmm.
what I also think is for me was a revelation was that I always been working with two band camps in audio. I had like the UK name, Lin, etc. Like timing,
Yeah. 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 Yeah.
energy,
Yeah.
everything has to really come together as musical performance. You have to feel the
Yeah.
emotions of the performer, and then maybe the technicalities were not always perfect, to be honest. But it had to sound like
It had.
music.
It has a. Those brands have a certain fun factor for me.
Yeah,
There's
and
this. I always want to dance
they they
if I
they
hear
get they
their
get the
stuff.
kind of, I would say, the fundamentals of the music,
Yes.
and they're
Yes.
willing to not go all the way on the technical parts,
Mm-hmm.
to keep the fundamentals where they should be. And then you can have another band camp where it's all about having a huge stage. It's all about timber, all of that. And then
Yeah.
usually when you get that, you don't really get the fundamentals of the music, that timing. So usually you have to kind of choose. And
Yeah.
what I
Balance in
found
between them.
but what I found was actually, if I could control the time domain, that was actually a key to both. It both
Yes.
tracked into the musicality, that this timing, this energy, that propulsion of the music was even better than I had heard it before. And then at the same
Mm-hmm.
time, also this soundstage precision, 3D depth, all of that also locked into place. So for me, it was sort of like, okay, this is really, really interesting because it's solving so many problems, audible problems, and I have
Yes.
one key um, area that I need to understand better to do that. So that just proved to be a very powerful tool. And then now reapplying it into crossover design, into cable designs of various sorts and so on, just seemed to be really opening up, but also system-wise proving extremely beneficial.
I was thinking about what we need because we're talking for almost an hour already.
Yeah, yeah. Time flies.
But time flies when you're having fun. It's always the same with my interviews. They always last for an hour or longer, but it's not a problem. But I think I know your idea. You can explain it very well what's important to you and why you build the cables the way you build them. What I wanted to say as a for yeah to sum it up is that even if you are in this business for decades and we did one attempt of measuring cables and find out what's important, even then you're not getting even close to how complex this actually is, and there are a lot of factors to keep in account. Capacitance, inductance, impedance, conductance, that's just the basics, and it doesn't actually tell you that much. I figured that out. For speaker cable, I still think impedance is important, but the whole timing thing was a revelation to me, and that was just this part of this whole story, and I'm triggered to find out more, but it is really, really, really complex. And next thing I think is going to find out how insulation works and what the impact is on sound, and maybe even shielding. But shielding is also a whole other aspect of cabling. You have the pros and the cons concerning shielding because you can get extra reflections and stuff like that. But you already know that. Um, for me, I think a lot of people should keep an open mind and just trust your ears. I mean, there are people that want to find out how you can measure it. We're not there yet. That's what I learned from this whole endeavor of measuring cables. And I think the same accounts to you. You use your ears and common sense to make a good cable, and you know a lot more about cables than I do. And if you even say we're not there yet, I don't think we're there yet. That's the
Well, I agree. I
conclusion of this
agree.
story.
And I think it's about being in audio, shouldn't be about just making a
Yeah.
living, or shouldn't just be becoming rich. I
No.
don't think that many people are actually getting that rich from audio, but anyway, I think that it's a journey for all of us.
Yeah.
So
Yeah.
we keep on looking, we keep on learning, and I I will never say that what we have done and achieved is then the end of the
Yes.
conversation. I would much rather say maybe it's the start, and then hopefully
Oh yeah,
the
we're just getting
conversation.
started.
Yeah, and the
Yeah.
conversation, I think, and this is also the reason why I think this interview is a really good idea, is that if we can elevate the level of the discussion, and then we can
Yeah.
have more interesting conversations about these things, so we kind of get a little bit away from the voodoo. And a little bit more into not saying that we do have the explanations, but that we
No.
also we are pretty much in the dark, but there are ways to navigate. And then,
Well, we are in
yeah,
the dark in that sense that we don't know enough to say this is it.
yeah,
And we had that talk before on the phone. Like, I try to draw conclusions from the data I have gathered, but I am very humble in this aspect that I don't know a lot about it. I just found out this kind of information. But I think we should acknowledge that we don't know a lot about building a good cable and what the impact is and why there is such a large impact on cables. We just don't know. But we try. And we're not NASA that can build rocket ships to go to the moon and beyond. But, there are some people that want to find out. And I know 4 or 5 of them that are actually very open-minded, very clever, and very, you know, um, eager to know more about it. And if those people that have much more knowledge than I do even say, we don't know, but we want to find out, that I think is a very positive thing, instead of just saying, we can't measure it, so it isn't there, because we just don't know what to measure. Let's be honest.
I agree.
That's
And to further add to the complexity of the system is not just, let's say, how we reproduce sound and music
no.
in the equipment. It's equally how we perceive it. So that side of
Yeah.
the equation, I think, shouldn't be diminished. And there is a tendency among
No.
some technical people to say, well, you're just like, they're using the mind as a way to discredit
Yeah.
potential
Yeah.
relevant differences in the system, the technical system. And I think this is a
Yeah.
very, very dangerous route. It's a very problematic route because they have no clue. Trust me, they think they have a clue about the technical things, but they have no clue
No.
about how the perception does, how that works. And I think what we have to
No.
recognize is that as human beings, we learn with our senses. So the way that we process information, how we make sense of it, is conditioned and connected to our senses. So we
Yeah.
have to recognize not just the limitations of our senses, but also the immense complexity of how we make sense of it. So there might be certain things
Oh
we are
yeah.
not that attentive to. For instance, I don't think that we are so attentive to noise than others would claim, but I do think that the timing aspects, that we're so much more sensitive,
Oh,
that we
very,
cannot
very.
cheat
Yeah.
the ears. So and
No.
and I think this is just a way of saying that it plays both ways, but it's about
Mm-hmm.
understanding that we have to design not just for the perfect measurements, because we don't really know what they should look like, but we have to
No, that's
design
an
for
whole
the
other
things
story. Yeah. Yeah.
that
Yeah.
reproduces the kind of audible effect or
Yeah.
lack of that we are trying to achieve.
True. But before we go into psychoacoustics, because I already made a link to that as a very interesting subject, and what do we hear and where are we sensitive to, I think we need to finish this interview.
Yes,
But maybe we can ask our viewers if they want to know more. They can put it in the comments, and we could schedule another talk. Maybe that
yeah,
could be fun. But let them decide if they want to have a part 2 of this interesting conversation. And we'll see. Okay.
definitely. Thanks, Jap. Thanks for
All
having me
right.
here, and I enjoyed the conversation. So to be
You're
continued.
very welcome. We had a lot of fun. Thank you very much.
Likewise.
And hopefully see you later. See
Likewise.
ya.
Cheers. Bye.